Thank you very much, Koen. Next speaker, I'm very honored to introduce Peter Vanhoof. I got to know him only recently, which is a pity for me because he has done a whole trajectory which is very, very exceptional, I think. I got to know him because I ordered a book he translated, I think more than 20 years ago, from a German scientist, and he translated it into Dutch, een biologische kijk op bodemvruchtbaarheid, by Hans-Peter Rusch. Yes. And when I ordered that book, I got to know that in the beginning of WERVEL, he was already involved before I was involved in WERVEL. So we had a kind of connection in different levels because I was doing a research on mixed farming operations and why mixing agriculture in the context of the mentioned Agromix project. And I got to know the work of Jaap van Bruchem on kringlooplandbouw, circular agriculture. To summarize, Wageningen did in an experimental station prove in 95 that circular agriculture with less concentrates and less artificial fertilizer improves the nitrogen use efficiency and improves costs or reduces costs for farmers, making everything more profitable. And Peter is, unfortunately, Jaap van Bruchem, who did that research at Wageningen, passed away, and I consider Peter to be a sort of carrying on the work of Jaap van Bruchem. Is that too much of an honor? In any way, in any case, you will enjoy what he has to tell.
So I am from Antwerp. I live since 25 years in Poland. And since about 12 years, I'm often in Holland and last years also in Belgium to make measurements on farms. Yeah. So I had the opportunity to meet the right people to make Avance, and I cooperated with people who were looking how to get an optimal dairy production, yeah, without losses. And then it was, of course, Jaap van Bruchem who had to do a lot of work before, but I had a little bit other approach by looking in the soil. And yeah, so that's the thing I would like to present to you. A little bit a summary of 12 years of measuring and seeing different situations. So to do these measurements, I have a mobile lab in my van. So I can easily make measurements on a farm. For me, it's important to have fresh samples to measure. So the lab comes to the farm instead of the samples to a lab. And here you see, for instance, my installation to measure here ammoniac emissions from a slurry sample. And with this, with the other device there, I'm measuring pH, redox potential, and conductivity. Yeah, so to get an idea about the situation. What's that? This should be turned over, but in one or another strange thing, it's, yeah. That's an example of my soil measurement report, yeah, where I'm checking a few things. I measure the pH and redox conditions to have an idea about the physical condition of the soil. Then here, thank you, it's becoming better. Jetzt now nog wat smaller. Ja, ofwel naar onder trekken ofwel smaller maken. Ja. It's about good now. So it would bring us too far to explain this thoroughly because I have not enough time for that. But what I do is I see three things: the nutrients which are available immediately in a time of 2 hours in the soil. So that are the salts which Anton spoke about. Yeah, these are the minerals here which have a direct action on the plant and which are a direct feeding of the plant. And this can bring a lot of disbalances and things we don't like. Yeah. The second thing is here, I test the mineralization of organic matter in the soil. I look how intensive is the respiration of decay organisms, what they do with the pH in the soil, and if they mineralize nutrients or they block nutrients. So they bind an excess of nitrogen. And here in this case, you see a mineralization from 85 kilo per hectare. I make this measurement by conductivity, so it's an overall interpretation of the nutrients. I cannot see which nutrients these are. Then in the rhizosphere test, I put a little bit of sugar in the probe and I can see what's happening when in a soil under ideal conditions, if the rhizosphere organisms or microbes become active. The sugars are then the substitution of root exudates. Yeah. So if I see a good reaction as we see here, 1,600 kilo per hectare, when at the beginning we had 365 kilo weak disponible nutrients, I say the soil life is bringing 4 or 5 times more nutrients than are available immediately. That's the best system because it's a nutrition on demand for the plant. So this is an example of a good soil analysis. But what I cannot see in the lab is the depth of the root development. So that's the reason I need to look in the field or the greenland, how deep root development I can see. So if we see here in the subsoil a mass of nutrients which are available by rhizosphere, but there are no roots, yeah, it's a potential we don't utilize. Yeah, in this case, root development was very deep, so we use everything. But the soil measurement is only a part of the whole food chain on the farm. And that I made here aside. In the center of the food chain is the farmer who should look with his eyes, not only papers and analysis, but also roots and worms and so on. Yeah. And he should look with his heart, not always with his counting machine. Eh? And so I measure the soil, I measure the food, here, the feed, the ratio of the cows with the water. I check the milk. I check the digestion of the food by controlling the dung. And I check the slurry or dry manure, according to what the farmer has. And when I have these measurements and I have seen the farm, I have talked with the farmer, together we come to a conclusion what would be the best thing to do in this situation. The technique is rather weak here. Now, come on, yeah. So here, we are used to use chemical analysis in agriculture, and then we look at the quantity of building materials, let's say. So if we look at these 4 pictures, we have the same amount of building materials in the 4 pictures, but there is a great difference in structure, which is important. Here you cannot live, here you can hardly live, here you can live some better, and here it's very nice to live. Yeah. The same quantity, other structure. So there we should look also. And what kind of life we need? First, we need a quantity of life. Lots of life or only a few on the same surface. Second, we need the quality of life. If we have plenty of this quality, this quantity and this quality, it will not be a big success, yeah? If we have this quality, but this quantity, it won't work either. And then we need also a place to live, a ruin or a castle, yeah? That's the difference. So a good soil structure. Now that's my plan to show, and again, some things has displaced, but okay. Here we have the bad situation in the soil. Let's say the conventional situation. We are overfeeding the plant with salts, mineral salts, so quick working ions. And here we have 1.5 ton of nutrients per hectare as my test result, yeah. And 40% of that are quick salts. So it's much too much. It means that the plant to transfer, that is mainly mineral nitrogen and potassium, to transfer it into proteins, the plant will need big amounts of sugar to transfer it. It means less sugar is over to feed, for instance, the rhizosphere organisms. So we get less sugar in the soil as we could have in a better situation. There is less soil respiration of the life, which becomes not enough sugar or root exudates from the plant. And we have a limited root development because the sublayer of the soil is much too salty. Yeah? We make it impossible for the life to develop in these conditions. Crop will grow quickly. Yeah, that's sure, but we will have the poor quality. And then this RM cow is eating this not optimal grass, and the slurry or the things which comes out of the cow, the urine and the dung, are of a bad quality and contain toxic things. So you don't see dung beetle in such cow shit. You don't find worms in it, simply because life doesn't like it. Yeah, it's not a good restaurant. And if ammoniac comes out, hydric sulfur, sulfuric gas, lachgas, I don't know in English, N2O, yeah, such nice things. Then when you smell this, you don't like to eat it. It's normal. So we get toxins from it, which come in the soil, and it's conventionally explained as mineralization, but it contains some toxic elements. And that's the reason when you give big quantities of slurry on Greenland from a poor quality, you give enormous nitrogen, but because of the toxic products in it, it will not functionate. It will not grow as it should. And you have here a putrefaction or a rotting from organic matter. Now, what's happening then? One is failing. Oh, there was nog an animation that we burn by these salts. When it's mineral nitrogen, we burn the organic matter. The soil becomes poorer. We become an enormous amount of carbon dioxide. So the plants will grow from there. So I think we could state that mineral nitrogen is pushing the carbon out of the soil, and this carbon in form of carbon dioxide is stimulating growth. So a big part of a nitrogen fertilization is a carbon effect on the plant. But because there is too much nitrogen in comparison with carbon, we burn down the carbon. Yeah. So from now we go to a happy end. That's the most worst case situation. We have the ruin, life is impossible. And now we go and look, how can we bring a solution? And then we should look in the whole cycle. And when it's, for instance, a farm with only arable land without animals, they should cooperate with a farmer who has animals. And there should be an exchange of animal or manure or slurry, because in nature you have always plants and animals. Yeah, you don't have in nature a place where there are no animals. So we have start from a poor quality. The feed trader advises the dairyman what they should feed. It's very independent. We are feeding the guts of the cow, not the rumen. So we had not too good rumen fermentation. That's had effects on milk quality, cow problems, and we become a manure with some kind of toxins. Yeah, because of too much mineral nitrogen. Then we could decide to take an independent feed advisor who isn't selling us anything. And he will say probably, oh, but you can give some less proteins. Maybe you should give some more energy. Yeah, sea minerals if there are lacking, or carbon in case of mycotoxins. But at the end, you will start feeding the rumen. It means you start feeding a ruminant as a ruminant. Quite important, eh? I wouldn't like to be fed as a ruminant being a human, eh? So the cows don't like it also, otherwise. So we get an optimal rumen fermentation. Cow problems are disappearing for the most part, and we get more organic nitrogen and a good manure, which will be a good restaurant for the soil life. So you see immediately dung beetles, flies, worms, all kind of biology which is starting to consume these things. And the farmer, when he has seen this development, he thinks maybe it's better to have an optimal production with low costs than a highest possible production with a lot of costs and with a lot of stress. Yeah. So he will earn more money in this way than in the way before. And in the further part of the cycle, we have at the beginning this bad slurry quality with all the problems with the emission, with the toxic things which come in the slurry pit. We give too much slurry on the field by injection, very much on a small part. On 1/4 or 1/5 of the surface, we give everything. So by giving 25 cubic meters per hectare, you give at least 100 cubic meter per hectare on this small, how you call it, slide. Eh? Yeah, you understand. Eh? So we have leaching out of minerals. We have a high yield, but with much losses, poor quality, disbalance of minerals. That are the Dutch things. So low energy, normal protein, but bad quality of proteins and too much potassium. Then when we got this better slurry, we don't have a putrefaction, but a fermentation. We don't have these emissions, so we preserve nutrients. In place of toxic things, we give rock dust or stone meal, carbon, microorganisms eventually. We give less slurry at once and on the surface, the old way. On every square centimeter of the soil comes 1 drop of slurry, and that the soil can keep. Yeah, maybe that you give 40 tons a hectare. Yeah, but on a sandy soil, I would say 10 tons per hectare gives the best results given at once. Yeah. The resupply of nitrogen we don't need anymore because it's better used. We want biodiversity. We get nitrogen from clovers, we get by root exudates and a very good symbiotic activity in the soil, we get sequestration of carbon, which will limit leaching. Yeah, with this animation, some things are going wrong. But anyway, a good yield and a yield certainty. And if we get the dry air and you have roots until 75 centimeters of depth, the chance that your prairie stops growing is lesser than if you have roots until 15 centimeters. Yeah. So we get a high quality food. And this high quality food comes then in the upper side of the cycle. We can give less concentrate then because the fodder is of better quality, and all of these, yeah, that's work, not, but all of these other things here, you can give less, and at the end you become a lot of milk from your own feed. It's not interesting to get a lot of milk from feed you should buy. You want it from your own land, yeah. And then we come to this situation. The salts are less. Maybe we are feeding slightly the plant with a small quantity of salts, yeah, but the main quantity goes over the clay-humus complex, also, so it's taken up by the soil and taken out by the plant by ion change, but mostly by a good rhizosphere activity. So massive root exudates, massive root development in the depth, in the width, and in all directions. And that gives a stable system. Yeah, I mentioned here also living humus. Yeah, not the dead humus where Richard talked about, but the living one, which can be used by life. And in place of toxic things, we become minerals from the mineralization of, or the decay, aerobic decay of organic matter. So in this case, the soil will be more and more rich in carbon, and we get all good things together. That's very rare. Most of the time, if we get one thing which is very interesting, we lose some other things because we are told you cannot have everything. But in this system, you have better and better soil quality with infiltration, with root development, with water keeping capacity. We get a better quality of food. We have no emissions in the environment, and these emissions are equal to financial losses for the farmers. Yeah, that's also a thing. They try also to do as if a farmer is an enemy of the environment. I would say if he's doing well, it's the opposite. Yeah. So that's good. Yeah, we get insects, we get birds who are living from these insects and so on. So diversity we get also. And yeah, that's the optimal situation. So we put carbon dioxide in the soil in form of humus. And then we have no longer a ruin, but a castle. Yeah. But then I see such things 2 weeks ago. That's called science. And so I'm very sorry, but here is simply told that with more carbon dioxide in the atmosphere, plants have less minerals and trace elements. It's the opposite. It's a kind of a mentality, if you would say, where we see fire, there are firemen. So the firemen are the cause of the fire. No, you change the cause and the effect. So here I know that if plants have lack of microelements, trace elements, they don't have as good photosynthesis activity as they could have. But carbon dioxide fertilization is very important and very underestimated. So that's I don't agree with this. I see in the practice the opposite thing happening. Yeah, because we are almost at the end, I heard.
Yes.
I need to show in that case one more slide. This one. We made a research in 2019 of 135 dairy farms. We took slurry samples in February. We checked the quality of the slurry and the emission from the slurry and compared it with the feeding of the cows in the winter before. And then we checked how this slurry is working on Greenland for the first cutting of grass. So how many yields we become and how many of the nitrogen is from the fertilized nitrogen is taken up and used. So then we have seen in the conventional system that we defined as follows: farmers who have given more than 25 tons a hectare at once in early spring, in February, with high nitrogen and high emission, and nog 50 kilo of artificial fertilizers together. Yeah, and the regenerative farming we defined as less than 25 tons per hectare. The slurry has been given in March with less nitrogen and no fertilizer. Then here at 100, you have 100% stickstoff efficiency. It's nitrogen efficiency. It means that the plant has taken up all nitrogen which has been fertilized. And in the conventional farms, the average was 68%. So 32% was not taken up. Yeah. The worst had 42%. And the best here in this, he had almost 200%, yeah, with an average of 100 to 22. It means, in average, they have become 22% of nitrogen more than they have fertilized by a good soil life. And the best from the best, they had almost the double amount of nitrogen, yeah. And at the meantime, when nitrogen was bad, the efficiency of nitrogen was bad, the efficiency of the other elements was worse also. Maybe for phosphorus and potassium, it was rather acceptable, but from the others, it was clearly worse. So that's the thing. And in that way, I think we should look at root development. I made so a device, but if you look here, and we take a soil sample until 6 centimeter in Belgium for Greenland and 10 centimeter in Holland. And we think we can explain how to fertilize Greenland with this soil report. Maybe here it will be correct because we have roots until 12, 15 centimeter. Yeah. But here, excuse me, you take a tiny top layer and you have roots until 60, 70, 80 centimeters. I think it's nothing. Yeah. So the combining of things you can measure with things you can see, smell, touch, that's important. You can see more on my homepage if you want. I have for now a Dutch, a German, and a new English version. So thank you for your attention and questions.
Thank you very much. Peter Vanhoof. You're lagging a little bit behind. I'm watching you for any question. Maybe I have a surprise for you, Peter.
Oh.
I'm looking for one of your companions with a wheelbarrow. Where is Theo? Theo, I promised you one, well, let's say, additional remark. Come here. Come on, come on. And in the meanwhile, I'm watching the audience, whether there are extra questions. Well, some acrobatic thing. Theo, you know each other, Peter?
Yes, yes, we know each
Okay.
other plenty of years.
A call to action. 1 minute.
Okay. This thinking, I think, that's a saying in Dutch, sometimes you need a wheelbarrow to come further. And this thinking, what we hear now, needs a wheelbarrow. And this is,
You're from the Netherlands. You want to come by wheelbarrow to Brussels, to the European Parliament. Why and when?
that's right. Last year, I walked with a wheelbarrow in Belgium. So 22 of April is the World Earth Day. And then we would like to come with wheelbarrows in Brussels. And then we want to
Filled with what? With soil?
with humus-rich soil.
Okay.
So the farmer of the future will be the doctor of the future.
What is your call to action?
The call to action is, here's a lot of energy. Who can help us that we make this happen?
And your message is, dear Parliament, members of Parliament, pay more attention to a healthy soil.
The healthy soil is the foundation. And
Okay, thank you very much. You saw Theo. Please take contact with him during coffee break to have further arrangements.
Marcel de Jong, he will help. So we need some
Okay.
more people. Okay.
Remember him. Are there any questions? Thank you very much. For Peter, everybody is awake? Here is my microphone. Okay, what's your question?
My question is, when you leave out the nitrates fertilizer, do you have any data on the liters of milk produced per day per cow?
Good question.
Every change should be in parts. So you cannot change your farm when you were used to use, let's say, 200 kilo of mineral nitrogen per hectare. You cannot go in one season from that to 0. Yeah, that will have bad results. So
What's your advice? In how many years should you decrease?
First, you try on one prairie where you are fertilizing otherwise.
Okay.
I have a group of 15 farmers in Gelderland, in the east part of the Netherlands, where I'm advising them for 4 years. And they started this year to use rock dust on the sandy soil on the prairies, on half of a parcel. And they see results. Yeah. Some started to give less ammonium nitrate. They see results also that there is coming some more clover, that the yield is the same, but the quality is better. This group is very motivated. So they are making these things in practice. And
okay,
yeah,
and if
so with small steps, you can achieve that, but you don't have to make a revolution.
And the question was, what about my dairy, my milking results?
Yeah, so if you are not too radical, it can cost milk if you give less concentrate. Yeah, that's clear. But then it's the question of the prices. If the concentrate is expensive or creates other costs as veterinary costs or something like that, or a worse fertility, then you should look if it's a good idea for you.
Yeah. And your answer is look at the net rentability.
The return, look
Probably.
at the return.
Yeah,
if you gain more money or less by doing a certain thing, but maybe more important from getting today more or less money from this system is look on your food chain. What's the effect of your activity on the further steps in your food chain? If it's destroying something further, then it's no sense. Yeah.
Okay, thank you very much. Another question? No questions anymore? Yes. I'm hurrying to the other side.
Good journey.
Last question. And then we have one speaker before coffee break, a farmer. Nearly there. There you go.
So, say you're as a farmer in the situation that you have a long-term good view of what your soil can do. So in a stable long-term relation. We are a baker, and we want to see in a reasonable way how many tons per hectare can be farmed without pushing limits, without exaggerating on any of the dimensions you just mentioned. Is it
How
like
many?
4 tons, 5 tons, maybe?
Are you talking wheat?
Wheat, yes.
Wheat production?
Wheat production.
Tarwe.
Yeah.
Tarwe. Yes, of course.
I
Tarwe.
suppose not the other wheat.
Cereals. No. Grain.
It depends on your soil. I don't do too much things with broadacre farms. It's more with dairy cattle farms, so with Greenland and so on. But Emil, who will have his lecture,
good.
by the way, he is a broadacre farmer, so he will have more experience with it.
Okay.
But the thing is, I think if you have 1.5 grootvee-eenheid, calculated cow, let's say, per hectare, in my opinion, you don't need any chemical fertilizer if you are working well.
Okay.
If you have more, you should work together with a guy like Emil, who has no animals but only acres, to give a part of your manure to him, so that both together you make one food chain then. Yeah.
You need to talk during coffee break and enter into detail. I'm very curious to hear the last speaker, Emil. Hi, Emil. You will be introduced by Jeroen. Thank you very much, Peter Vanhoof.
And Jeroen asked me to introduce Emil because I know him better.
Off you go.